Okay, semester review video. Please refer to the PDF upload of the actual answer key for formulas and such as that. They're highlighted and everything's nice and neat. So, because I'm going to be going through this a little quickly, just so you can get a little refresher on all of these. Rewriting equations as logarithms and exponents as logarithms, whatever. That's just remembering where to put what. So like in number 1, the base of the logarithm is always the same as the base of the exponent. What it's equal to goes behind the logarithm, and your actual power is what it's equal to. So number 2 is just that backwards, right? So the base of the logarithm to the -2 power is equal to 1/16. So that's pretty easy. Number 3, there are a lot of different correct ways to do number 3. To me, I just kind of use my calculator as like a little guess and check. Like, I know this means this is 6 to some power has to equal 1,296. So I just grab my calculator real quick and be like, okay, 6 to the, third power? No, 6 to the 4th power, whatever. This one happens to be, I believe, 6 to the 4th power. Yeah, this one happens to be 6 to the 4th power, so that means that the value of the logarithm is 4. You could also use the change of base formula. That works really well. The problem is probably a little less guess and checky, but whatever works for your brain on number 3. But that's all you're doing. You're just trying to figure out what the value of the logarithm is. Number 4 and number 5 are using those logarithmic rules that we learned, the power quotient and product properties. So like number 4, like I know the 6 and 8 can come up and become exponents. So it's going to be v to the 6th power, x to the 8th power. And if you're adding, you can always combine it using multiplication or subtraction with division. And so this is going to be a log with the base of b, right? That is the base. And again, it's going to be v to the 6th power times x to the 8th power. So you're just condensing that logarithm. The number 5 is the same thing but backwards. I don't have any exponents on this one, so I don't have to worry about the power property. And obviously I'm dividing, so that goes with subtraction. So that's going to be log base 4 of c minus log base 4 of 5. So expanding it creates more logarithms, and condensing it, you're writing it as a single logarithm. Number 6, I'm going to come down here to do number 6 just so because I have a little bit more room. You're just solving. This is actually an exponential equation. It's just the exponent happens to be an e. Remember, e is associated with a natural logarithm. So I'm going to treat this just like it was a 2-step algebra equation. Like I'm going to subtract 12 from both sides first. So I get 6 times e to the 3x equals, 17? And then divide both sides by 6 to isolate that e to the 3x power. And I'm just going to leave it as 17 over 6 for right now. No reason to try that as a nasty decimal because that's exactly what that is. So to get rid of this, I can use the concept of knowing how to rewrite. Remember, we know that log base e is the same thing as the natural log, right? So I can rewrite this as the natural log of 17 over 6 equals 3x. You could also, another option would be just doing the natural log of both sides. So if I did the natural log of 3 to the e to the 3x times the natural, or equals, it's late, I'm doing this quickly, is equal to the natural log. So you could do it that way also. So these are 2 different methods to do the same problem. The one on the left is just using that same property we did in number 1 and 2, rearranging it because we know that this is a thing, or you could just take the natural log of both sides. Regardless, you're going to end up with 3x equals the natural log of 17 over 6. Now, the natural log of 17 over 6 I can do in my calculator, and since this is just an equation, I know I'll be just dividing both sides by 3 anyway. So that's what I'm going to do in my calculator. I'm doing the natural log, if I can find my button, of 17 over 6. And get that really nice decimal. And then divide that by 3. And I get, what does it say to round to? It does not say what to round to. So I'm going to round it to like 3 decimal places. 0.347 is what you get there for number 6. Number 7 is also obviously a logarithm. Log 2x minus log 3 is -1. Okay, so the first thing I'm going to do is I'm going to use the property we did up in number 4, and I'm going to condense that and make it one logarithm. Now, since it is subtraction, that means I will be dividing, so it's going to be the log of 2x over 3 is -1. Then I'm going to use the property that we used up in number 2, and I'm going to change this logarithm to an exponential problem, so that, remember, if there's not a base, we know that's an understood 10, that's our common logarithm. So that's going to be 10 to the -1 power is 2x over 3. 10 to the -1 is 1/10. So I just need to divide both sides by 2/3. Remember, whenever you divide by a fraction, you're really multiplying by its reciprocal. So that's just going to be 3 over 20. So x is 3 over 20 for number 7. Number 8 is my last logarithm equation. So I'm going to do that one right here. This is another natural log, obviously. The natural log of 5x plus 7 is 6. Okay, so this one, like, there's nothing to do other than just start with, again, the same concept that I did back on number 2. I'm just going to rewrite this. I know natural log is the same thing as with log base e. So if I rewrote this as an exponential, this would be e to the 6th power equals 5x plus 7. And it's a 2-step algebra equation. I would have to subtract 7 from both sides. Now, again, this is going to be a really not nice decimal, so I'm just going to go ahead and write it out. All right, so I'd subtract 7 and then divide by 5. And that's precisely what I'm going to be entering into my calculator. E to the 6th power minus 7. And then that answer divided by 5. And they do ask me to round to the nearest thousandth on this one specifically. So that's 3 decimal places. That'd be 79.286 for that one. So logarithms, that's what we started off the semester with. And then we moved on to trigonometry. So number 9, I'm trying to decide if I want to go back up or not, if I just want to stay on my line paper. Okay, so I'm just going to do number 9 right here. Number 9. If you recall, sine and cosine has to do with our x and y values on a unit circle. And since 16 and 12 is obviously not on the unit circle, then I have to find the length of the radius. And we did that by basically doing the Pythagorean theorem, right? X squared plus y squared is r squared. And so obviously x and y is 16 and 12. So 16 squared plus 12 squared will give you the radius squared. 16 squared plus 12 squared is 400. So that means the radius would be 20. All right, take the square root of 400. And our trig identities that we did, remember, sine was y over r and cosine was x over r. So that means that sine would be 12 over 20, or, my brain just turned off, 3/5. And then cosine would be, what was it, 16? Yeah, x over r, so 16 over 20, or 4/5. So that's number 9. I would suggest writing down those properties. It is just the Pythagorean theorem, though, on that one. Number 10, it asks, what is the sine if cosine is 5/13 and it's in quadrant 4? and a couple of different ways to do this one correctly. I honestly would use the Pythagorean identity because that's going to be the easiest way to do number 10. You could do it just like we did number 9, but I'm going to use the Pythagorean identity. The Pythagorean identity is just that. It's the Pythagorean theorem. We had one of those on our post test that we just did on Study Island. We actually had a couple of those. So sine squared, cosine, they said is 5/13. So 5/13 squared is 1. So sine squared, that's 25 over 169 is 1. Now listen, I know we love our calculators and we know we love decimals, but this is not the time or place for it. So 1 over, that's a 9. Why did I write a 5? 169. So what is that? 169 minus 25 is 144. I don't even know why I'm typing that in my calculator. So you get sine squared is 140 of theta. It's 144 over 169. I'm trying to go too fast is my problem. And obviously that's sine squared, so you'll have to take the square root of both sides. So if I take the square root of 144 over 169, the square root of 144 is 12, and the square root of 169 is 13. So my answer is 12/13. So the Pythagorean identity. Again, please do not give me a decimal on this one. I will implode and then mark it wrong. Number 11 and 12, you're just going from radians to degrees and vice versa. I'm going to come back up here for that one because that one's really short and easy. If you're converting from degrees to radians, you're just going to take your degree measure and multiply times pi over 180. So really all you're doing is reducing 110 over 180. So it would be 11 pi over 18 would be the correct answer for that one. So number 12 is the same thing, just upside down, right? I have my my radian measure. So I want to change it to degrees. So I'll multiply times 180 over pi. Remember, those two are always constant. Let's see, 7. Oops, I hope if I use my calculator correctly. So that one's going to be 126 degrees. That's what you end up for that one. All right, number 13, the period and the amplitude. So first of all, let's do the amplitude. It is the easiest one. It's whatever the number is in front of your sine or cosine. In this case, it would be a -2. Remember, all the negative does is flip it upside down. So the amplitude of this one is just 2, meaning from our midline up and our midline down, it would be 2 units. The period comes from the number that's in front of the x or your theta. There is a formula for period. It is 2 pi divided by whatever that number happens to be. We called it b. In this case, it's 1. So if it's something else, you're going to do 2 pi divided by whatever that number is. So for this particular problem, it's 2 pi divided by 1 or just 2 pi. So just be careful about that one. So the amplitude and the period. Remember, the period's the length of the wave. So 14 and 15, these are translation ones. These are super easy. We've done translations literally since last year. And you'll get to do them again next year. I know you're so excited. But they're super easy, right? We know if it goes up or down, that number is being added to or subtracted from the function and not the x value. So since I'm moving up, it would be cosine of x plus 6. And, like I said, our left and right movement, the horizontal shift, that's the one that's backwards, right? I mean, you're changing the x value, so you're adding or subtracting it to the x value. So for this one, it would be y equals cosine, and then in parentheses, x minus 5. Remember, plus and minus are a little different with our horizontal shifts, so it is a minus because it's right, which I know feels opposite, but that's that. And then we moved on to matrices. Number 16, I do have to multiply this first matrix times a -2. So in order to do that, I'm just going to scalar multiply it. So that would be -12 negative 2, negative 2, positive 16, negative 4, and positive 6. And then I'm just going to add that to b. So plus b, 4, 3, negative 4. And I'm just going to do that. So when I add these together, I'm just going to make sure and be mindful of my signs. So negative 19, 7, 1, 20, negative 1, and 2. So that one's pretty easy. On 17 and 18, show your work. Okay, show your work. Show your work. Show your work. I'm going to do that down here. Number 17, you're multiplying two matrices together. Let's see. Whoops. My paper's flying away. Negative 4, negative 2, 1, and negative 8. And then we know since these are two square matrices, obviously you can multiply them together. So, not a problem here. Remember, it is rows by columns, right? So, as I go across, I'm going to go down. Negative 4 times negative 1 plus negative 2 times negative 7. It's first row, first column. First row, second column would be negative 4 times 0 plus negative 2 times negative 6. First row, second column. I'm going to do second row, first column. 1 times negative 1 plus negative 8 times negative 7. And then second row times second column would be 1 times 0 plus negative 8 times negative 6. Okay, so I need to see that. And then just multiply and add. So that's what this is. 4 plus 14, negative 1 plus 56, 0 plus 12, and 0 plus 48. So my answers are 18, 55, 12, and 48. That's number 17. Number 18 is a 3 by 3 determinant. I do not care if you choose to use expansion or the diagonal method. I do believe the diagonal method was the most popular, so that's the one I'm going to do now. If you do want a refresher on how to use the expansion, please let me know, and I will happily sit down with you in class, and I'll refresh your memory on how to do that. That is my preferred method, honestly. But if you're going to use diagonals, all you do is you repeat the first two columns. It's just going to make our life a little bit more easy. And then I'm going to go, just like if I did a regular determinant, I'm going to go left to right. Just like that, I'm going to multiply those together. So I would have negative 3 times 0 times 0 plus negative 3 times 1 times 4 plus 2 times 3 times negative 1, which would be 0 plus negative 12 plus negative 6, correct? And that would be negative 18. Okay, so that's my left to right diagonal, and then my right to left diagonals are going to be these. So that would be negative 3 times 0, negative 3 times 1 times negative 1, and 2 times 0 times 4, which is going to give me 0 plus 3 plus 0, which of course is 3. And remember, it's negative 18 minus, that's always going to be minus 3. So my answer here is going to be negative 21 for the determinant on 18. And then the last two are just some of the stats that we just got finished doing, trying to keep it doable within our time frame. Number 19, it's just remembering which measure of central tendency best describes the data based on the graph. So here in this histogram, it is obviously right skewed. So, whenever it's skewed, you always want to use the median. for your center and the interquartile range for your spread. All right, we just got finished doing that, so that should be fresh in our mind. And then number 20, you're going to need to sketch the normal curve, which I feel like we should be, again, well versed on it. We just got finished doing that. We have our mean, of course, is in the middle, is 85. And I'm just going to kind of fill it in as I go. Remember, this was 34, 34, 13 and a half, 13 and a half, 2.35, and 0.15. And you're just going to go up and down your standard deviations, right? Well, honestly, I'm not going to bother doing all of it because, like, I know if I go up one standard deviation, that's going to be 91, and that's what the question is asking us, is what percent of scores are less than 91. So that's going to be everything from 91 down. So that's going to be 84% of the scores are less than 91, because if you add all of those percents up, that would be 84%. So I suggest practicing this if you haven't already started. And let me know if you have any questions.